Hello, and welcome to our lecture on population and demographic transitions. The concept of demographic transitions is pretty crucial in both cultural geography as well as world regional geography. So, depending on which course you're taking, this is applicable for both. So, we're going to start off talking on how we calculate population and where we see different population clusters on the planet before we get into some of the specific measurements of different demographic principles. So first off, where do people live, right? We have a pretty big planet, so where are folks living, all right? So when we look at the geographies of health, of where babies are born, of where folks are dying, we kind of have to look at the population numbers, all right? And we can measure populations in several different ways. A very popular one is population density. So this is the number of people per area of land. So for example, I did some calculations for this lecture and I simply took the entire population of a country and I divided that by the entire land square area of that country. I did not include ocean because people don't live in ocean, right? We live on land. And that's one way of calculating population. And so it's just number of people divided by square kilometers of your country. Okay. You also can make this the arithmetic population density. And this is when you average that across an entire country. So this is the number that you're most commonly going to report. You're going to say it's population density, but you're actually averaging it for an entire country. Okay, so for example, if we look at some 2018 estimations from the CIA World Factbook, the United States had roughly 36 people per square kilometer. Okay, and that number is kind of hard to, picture, especially since, well, the US does not use kilometers. So first you got to think about how big is a square kilometer, but then we're like, what does it mean to have 36 people in one square kilometer? So we can compare that to other parts of the world. So, for example, Bangladesh in South Asia had 1,225 people per square kilometer. Japan had 346 people per square kilometer. Again, all of this is 200 or 2018 estimations. And so, as of 2020, if we look at the entire population density for the whole planet, it's roughly 51.6 people per square kilometer. Okay, so you can say that the US has roughly less dense than the population global estimate versus both Bangladesh and Japan have a much higher population density. Okay. So this is kind of what that looks like visually. I'm more of a visual person. You might be a number person, but if you are more of a visual person, this is a great example of how we would map that. So this is from CDAC out of Colombia. Thank you so much for letting us use this map. And so this is looking at the number of people per square kilometer. All right. So obviously the darker the red, the higher the number. Okay. So again, we've got our Bangladesh is going to be over here versus we have Japan over here and then US over here. You can kind of see where there's more people clustered versus less people clustered. Okay. Again, the darker the red would be the higher the density of people per square kilometer. All right. Now, the problem with population density, by just giving you one number, is that humans are not evenly spread out over the planet. That's one of the main features of studying world geography and human geography is where do people live and why, right? Humans don't live everywhere on the planet. We're not evenly spread out. Big chunks of our planet are not very people friendly. So, living in a desert, for example, is very difficult for humans. Mountain areas, tundra areas, of course, there are cultures that have adapted to do so, but if you look at the wide number of humans, most of them are not clustered in deserts or tundra. So, just for an example, we have a photograph of Egypt here. This is one of the deserts in Egypt. 98% of the population of Egypt lives in just 3% of Egypt's total land. So, if I give you a number of population density for Egypt, and I just take the entire population of Egypt and divide it by the entire square kilometers of Egypt, you're not going to get a very realistic number, Okay, because that number is going to pretend like people live evenly in Egypt when they don't. And that's just a function of the physical geography landscape of Egypt, right? There's, of course, a major river in Egypt that more folks are going to live around versus the large desert. So instead, we use something called the physiologic population density. And we have to talk about something called arable land before we can talk about physiologic population density. So, arable land means a land that can be used for farming and agriculture because humans have to eat, right? If we don't eat, then we don't survive. So, if we look at a population of a region or a country or a realm, we have to think, how are those folks feeding themselves? And of course, there are many countries that rely on fishing. But for arable land, we're looking specifically at farming and agriculture. What percentage of my land is able to be used to produce food? Okay. Obviously, it is possible to farm on mountains. It is more difficult. It is possible to do types of agriculture in the desert. It is more difficult. And so, arable land is going to then look at a much smaller percentage of the land area of a country or a region. Okay, a much better idea of how much land can actually be used by humans. This gives you a more accurate representation of how humans are spread out within that country. So this physiologic population density, instead of dividing by that, so for example, looking at Egypt again, that 2013 population density, if I just look at the entire square mileage of the whole country, I've got 220 people per square mile. But then if I look at just that arable land, the land that's usable for farming, which in Egypt is not very much, right? It's like 3%. If I look at that physiologic population density, I have 6,800 people per square mile. So considerably more dense. So these are two very different numbers, and they give you two very different stories of where the population in Egypt are spread out. So you can see why the physiologic population is going to be much more useful if you're looking at how closely together folks are living. If you just want to look at number of people versus size of a country, then you can just do the standard population density or the arithmetic population density instead. So, number one thing that geographers want to talk about is, how do we make a map out of this, right? We got to map it. So, dot maps are a very popular way of mapping population. This here from your textbook is a dot map that shows each single dot is going to be a city that has at least 1 million people as of 2006. So, it is a bit old, right? As of 2006. So, every single red dot here shows you a city that has at least a million people. So you can see what parts of the world have more large cities. The previous map that we had from CDAC was going to be showing you, each dot was going to be a number of people, but the color also changed as well. So throughout today's lecture, you'll have some maps that are going to just have you color changing. Of course, this is problematic if your audience is no longer accessible to those who might be colorblind. So something cartographers want to think about when they're creating their works is this accessible to everyone who has different ranges of color vision? Okay, so this map here, every dot is a city that has 1 million people. This, of course, excludes all the folks living in cities that are less than 1 million people. So, for example, my city is less than 1 million people. So, my city is not on this map, right? So, it does exclude those who might be in more rural areas. Again, in an earlier lecture, we talked about the percentage of the planet in different parts of the world that are urban versus rural. That's going to vastly change depending on where you're at. So this does tell a specific story. Again, remember, when you make a map, you are choosing what story to tell. But the most important thing on this particular map is it highlights our three population clusters, and that's going to be East Asia, South Asia, and Europe. Now, we've already touched on our European lecture for those of you in my world region lecture or my world regional course, and then we're going to go on to South and East Asia after your first midterm. But you can see just from this map here how those are going to have a much higher cluster of these very large cities. So let's go ahead and look at those three regions in a little more detail. Okay, again, East Asia, South Asia, and Europe. So we're looking at East Asia. Some of the countries we're going to have in East Asia are China, North and South Korea, and Japan. And almost a quarter of the world's population lives in this area, in this region. We have a lot of large cities, as you saw in that last map, especially in China. And we do have some major river systems. Okay, so we have the Yangtze and the Yellow Rivers, very large river systems that are then going to provide fresh water, power in terms of dams on these rivers, as well as access for farming. In fact, there's a lot of farming in Eastern Asia, both in terms of rice and wheat. All right. You do still have, even though you have a lot of large cities, you have a lot of people living in rural areas, more farming communities, again, that rice and that wheat. So you do have a large urban population, but a lot of people are not in urban areas. Okay. South Asia, that's going to consist of India, Pakistan, Bangladesh, and Sri Lanka. Again, we have more major cities, all right? So very large cities that have in excess of 1 million people. And you also have some major river systems. We have the Ganges River and then the Indus River. Okay, you'll see a theme here, lots of rivers, right? Humans need water. If we don't have access to water, humans tend to not do very well. We do see this region rapidly growing. However, it is much more physically confined by mountain ranges. Okay, as we go and talk about the South Asia region in future lectures, you'll see we have the Himalayas in the north and the Karakoram in the west. Okay, and so we are going to have much more restriction space in terms of where folks can move, simply because of the basis that there is a mountain ranges restricting the spreading of cities. And then the third is going to be our European cluster. This cluster is significantly smaller than the other two. It's less than half of the South Asian cluster. And there are a lot of rivers in Europe, right? We talked about multiple rivers in Europe. However, the distribution within Europe is not based on those rivers. Instead, it is based on coal fields. And this is a direct response to the spread of the Industrial Revolution in the 1800s. As folks had more of a need for coal in order to power all of our steam engines and such, we had to open up new beds of coal, and so we see more of a spread moving westward, or no, eastward, in response to that. Okay, so you see much more population movement on coal fields and not on rivers. So different than East Asia. South and East Asia. On top of that, overwhelmingly within Europe, more folks are living in cities than they are on farms. So this is kind of the opposite of East and South Asia. Um, our entire planet is becoming more urbanized. More and more people are moving to urban areas and cities. But Europe is even more so than what we see in East and South Asia. So a different type of clustering of folks where they live. So more coal fields and cities versus East and South Asia are going to have more of a rural emphasis along rivers. Okay. Well, what about North America, right? So a lot of folks say, "Hey, wait a minute, we've got big cities too. How come we're not? We're not a major population center." So if we look at Canada, of course, much less sparse. Mexico is most often actually put within the Central American realm as well. But then if you look at the United States, even within the large cluster here in the southern portion of Mexico, and then going into South America or Central America, you don't have nearly as much of that density that you do in South and East Asia or within Europe. But we do have a different type of geographic phenomenon, and this is what is called a megalopolis. And so, megalopolis is going to be this big chunk of orangey red over here on the eastern seaboard of the United States. And this is going to be when you have a massive chunk of cities that kind of all blob together. Okay, so over here you've got Boston, New York City, Philadelphia, Baltimore, Washington, D.C., right? You have multiple very large cities that again kind of just blob together, and you have all their suburbs as well. Okay, so people who will work in Baltimore but live in a smaller city outside of that, possibly even outside of Maryland, right? A lot of folks commute here, so you might, live in New Jersey and commute into New York City, for example. So this, blob of population here contains over 20% of the entire U.S. population. So yes, Los Angeles is dense, and yes, San Francisco has some big suburbs, but nothing compared to this right here. Maybe dense is not the right word for Los Angeles. I should say sprawling, right? A lot of people live there, but nothing compared to what we see on the Eastern Seaboard. So again, this is going to be a megalopolis where you have so much urban interface that it kind of just becomes one giant mega city, right? Although, of course, these five cities have very different personalities. Ask anyone from Boston or New York City or Philadelphia, and they have very different city cultures than the other cities listed here. Okay, so now we've seen where people live on the planet, and let's talk about what kinds of people live where. And by kinds, I mean age and gender. Okay, so demographics is refers to what types of people, again, mostly talking about age, and how many make up a population. All right. There's a lot of vocabulary and a lot of math terms that we're going to use in this section here because a lot of demographics is about counting people. So, for example, census is one way that we count people. It is one of the more reliable. It is not the most reliable because, of course, depending on what country you're in, there are a lot of politics that influence who gets counted and why. Something that we're experiencing very much in the United States about who is being counted and why, and different barriers that might be coming up to how different folks are counted. Okay, some of the statistics that we use to discuss demographics are going to be something called dependency ratios. This is looking at the number of people who are dependent on someone else to provide a source of income, so people who are not working. Total fertility rate, so how many babies are being born per woman. Something called natural increase, which is going to be removing immigration from a country's population. And as we see in different parts of the world, immigration can have a major addition into different populations. So removing that number is going to have consequences for your population. Crude birth rates. This is just the number of live births per year per 1,000 people. Yeah, we have babies who are born alive, and this is per 1,000 people per year. And then the converse of this would be crude death rate. So the number of deaths per year per 1,000 people. Okay, so again, this is just counting numbers. And of course, there are many ways that these numbers might not be entirely accurately calculated, right? So, babies who are born in rural areas or places that maybe they are delivered by a midwife or a local woman versus a hospital, so they might not be counted until much later. After their birth, right? For a home birth, for example, might not be reported to a hospital right away. Some countries don't have a very strict way of counting babies. Again, especially if you're in a more rural area, those children might just not get counted until much later. Same for death rates. Not all deaths are reported. If you have a home burial in some parts of the world where maybe a small village, total number of deaths might not be reported. Of course, people who may go missing also may not be counted as a death as well. Okay, so how do we make our population get bigger? Okay, that's kind of something that many populations are looking at is I need people to work and bring in income. So how do I do that? And there are two ways to add to a population. You can have immigration, so folks coming into your country from a different country, or you can have babies, right? Those are the two ways that you add to your population. So, natural increase is going to refer to just the number of deaths and births in a country. It does not look at immigration or immigration. Okay. So, immigration with an I is people moving into your country, and emigration is people moving out of your country. If you have someone immigrating into your country, that's going to add to your population. If you have someone immigrating out of your country, that's going to subtract from your population. Okay. Natural increase, however, does not look at either of those numbers. So we simply take the number of deaths, you subtract it from the number of births, and you get a raw number. Okay. Now, when we look at how different countries' populations are changing, Comparing total population change versus just natural increase can give you some very, very different numbers. Okay. This is going to relate to what stage of demographic transition different countries are in. And you'll see increasingly, especially in Europe, a lot of European countries are very dependent on immigrants coming in, largely from North Africa. Also from, well, I should say from all over the world, but a lot of folks coming from North Africa, very dependent on that labor source. Okay. So this is going to be this is from 2010 to 2019. This is from the United Nations. This is the average annual rate of population change. Okay. So the darker the color means the more population change rate is, so higher numbers of change, versus the lighter colors are going to be negative. So for example, we see here much of Europe, much of this is going to be negative number. Okay, these are negative. So if we look at just and I believe this is just looking at natural increase. Um, this is going to be populations are shrinking. Okay, versus here populations are growing. For context, the United States, I think, was like zero point 0.4 or something. It was less than one. But yeah, you can see that populations are not changing evenly across the planet. There are some parts of the world where populations are growing, and some parts of the world populations are shrinking. And there are many, many, many factors that go into that. Okay, so again, the idea of fertility. So we're going to not look at immigration for this lecture. That will be another separate lecture later. So looking at just fertility, okay, total fertility rate is looking at the average. We're thinking in averages. The average number of children born to each woman during her reproductive years. Now, of course, reproductive years is a very broad number. For some folks, it starts at 16. Some people it starts at 12. It can end at 40. It can end at 70, right? So that's kind of a moving target already. But if we look at the average number of children born to each woman during her reproductive years, okay? If we're looking at just maintaining what's called replacement level, right? So if I have two people, a man and woman who are producing children, that's two people. When they die, I have to have two people to replace them if I want my population to stay stagnant, to stay even. So the replacement level for a country is going to be 2.1 children. Each woman must have 2.1 children. Why point one? Well, not all children make it to adulthood, unfortunately, right? So that 2.1 is to make up for the child who may die in infancy or may die as a teenager, whatever child doesn't make it to adulthood. Okay? So, in order to keep your population just looking at natural increase, not looking at immigration, in order to keep your population completely at level, that replacement level, each woman has to have 2.1 children. So, your fertility rate would be 2.1. Now, as we'll see, not all countries have that number. So, for example, in Bosnia and Herzegovina, it's 1.33. So that means each woman is having on average 1.3 children. That's not enough to replace a parenting couple, or I should say, a reproducing couple when they pass away, right? So that's not enough to replace the reproductive parents. Okay, so 1.33 people. So now we see Bosnia and Herzegovina's natural increase is going to be decreasing. Right, their natural non-immigrant numbers are getting smaller. Okay, Uganda, on the other hand, is 5.44. Okay, so their number is going to be increasing. On average, each woman is having 5.44 children in her lifetime. Okay, so that brings us to the idea of dependency ratios. If we're going to be having babies, well, how do we feed them? All right, and if we look at the changes in countries in terms of fertility rates, we also have to think about how these numbers have changed over time. Both of these numbers are 2020 estimates from the CIA, but you can find lots of maps that show how that has changed over history as well, because what we how we utilize children in terms of income, in terms of labor, has changed as we've changed our modes of income. In other words, not as many kids are working on the farm as they used to be. Okay, so this brings us the idea of dependency ratios. So if I'm going to have children, how do I pay for them? If I'm going to have elderly parents, how do I pay for them? Okay, so at certain points, we're unable to work and support ourselves, right? When we look at dependency ratios, we're looking strictly at age. There are, of course, other reasons why folks are unable to work through disability or illness. But if we look at the old age dependency ratio, this means the number of people over the age of 65 per every 100 people working between the ages of 15 and 64. Now, 65 is kind of a funny number because I know lots of people who are over the age of 65 who are still working. I certainly hope that I'm still working over the age of 65. But 65 has kind of been this magical number, especially in the United States culture, as the retirement age. Okay. 60, 62, 55, depending on what organization or agency you talk to. But 65 has kind of been the magical retirement number, right? Even though, of course, many people older than that are still working. But if we look at the number of people over 65 who are then dependent on people between the ages of 15 and 64 to then work and bring in a source of income for them. And then the flip side to this would be the child dependency ratio. So this is looking at the number of children under the age of 14. Now, of course, I know many people who started working below 14. Many of you may have started working at the age of 14. I think my first job, I was under 14, actually. So again, this is the number of children under 14 per 100 people. Okay. This is, of course, assuming that people under 14 over 65 are not working. We all know that's not true, but that's one way of looking at dependency is how many people are working and bringing in money and income for people who are not working. Okay. This number is more and more important as we see demographic transition progress into stage 4 and 5, which will come at the end of the lecture. Because if you have a very, very large number of people dependent on a small working population, that becomes problematic, right? If I have 100 people over the age of 65 dependent on 100 people working, it's very hard to make that income work for everyone who needs, food and shelter. So this number 65, once upon a time, you retired at 65 because you died at 65. And that number has changed in some parts of the world, but not all parts of the world. So this is life expectancy in 2019. And as you can see, it is all over the place. The 2019, the country that had the highest life expectancy was Tokyo with about 85, I believe. All right. And so you can see our purple countries are going to have much higher life expectancies versus our oranges and yellows are going to be in the mid 50s, or in some places early 50s, mid 50s to 60s. Okay, so folks are not living the same number of years across the planet. In our Russia lecture, we already talked about some of the economic and cultural factors that impacted especially men in Russia with higher rates of alcoholism following the fall of the Soviet Union. Um, so you can see that people aren't living the same amount of years over the world. And there are, of course, many factors that go into this. Access to healthcare, access to social programs to support retirement. Are you even able to retire? And of course, this is also an average. That's our favorite word, right? Average. And as you see the note on our bottom, this is from our World in Data. Um, the note on the bottom, this is the average number of years a newborn would live if the pattern were to stay the same throughout its life. And this is a very common critique we hear when you hear those urban legends of like, oh well, if we were still in George Washington times, you all be dead at 30. And someone's like, that's not true. Plenty of people lived past 30 in George Washington's time. Yes, many people did live past 30, but unfortunately a lot of people did not make it to 30. And so when we calculate life expectancy, we're taking the average number of years. And so when you have lower numbers, there are plenty of people who are living very long past past this, but unfortunately, a lot of folks who are not making it there at all. And that brings us to our saddest statistic, which is infant mortality and child mortality rates. So, this is the number of newborns who die before reaching the age of 1. This is as of 2017. And so when we look at historical data and say that, the average lifespan of a, ancient Rome was, 18 or whatever the numbers are, a lot of that is looking at the high number of children who did not make it out of their infancy and out of their childhood. Okay. There are many things that influence the death of children. And you can see parts of the world where the numbers are going to be highest, and you see parts of the world where the numbers are might be higher than you'd think. Okay, so the US actually has a much higher infant mortality rate than a lot of our so-called westernized cousins in Europe and in Canada and Australia. Okay. So there are many things that cause children to pass away, and you can find lots of links. Actually, our World in Data has an entire report looking at the different causes of death. But again, this is going to be access to healthcare, access to prenatal care, access to different types of birthing facilities, right? Whether or not we need to have a medical intervention for a birth or maybe a preterm birth. So this is going to be something that throws off some of your numbers in terms of life expectancy. It's not just that we all drop dead at 55, it's that not everyone makes it to 55. All right. So infant mortality is going to be death before the age of 1. Child mortality is between the ages of 1 and 5. You also can find something called youth mortality, which is going to be looking at teenage birth before the age of, I think, 15. And this is going to be number of deaths again per year per 1,000 babies. Okay. So Sweden, if we're looking at 2020, 2.6 babies died that year, or estimated to die that year per 1,000 babies. Japan is one of the lowest at 1.9. The actual lowest is Slovenia at 1.7. In comparison, the U.S. does not have a very good track record, 5.3, which is pretty high for a westernized country. And then the highest in the world is Afghanistan with 104 babies dying per 1,000 babies. Okay, so again, where you live on this planet is going to dictate a lot about your life, your quality of life, especially in terms of access to clean water, access to hospitals, hospital beds, number of doctors per people. All those are numbers that we look at as we look into demographics. We see where do people have access to healthcare? Do they have access to different types of food, and so on and so forth. Okay. Now, just like we saw that map of the world that showed that infant mortality is different across the world, the problem with those IMRs, those infant mortality rates, is they're just an average. And average numbers erase a lot of the details that's necessary to do important policy and public health care work. So, for example, if we look at just the United States, that 5.3 in 2017 is 5.8. That 5.8 number of babies per thousand babies, right, is not evenly spread across the entire country. So even within one country, okay, we see much higher rates of infant mortality in the American South and some of our more rural countries, and we see much lower numbers of infant mortality on the coasts, right? And so, why is that? North and South Dakota are right next to each other, and you have two extremes here. There's a lot more that goes into access of healthcare than just what country you are, right? Your ethnicity and race will have a lot to do with your access to healthcare, or the treatment by your doctors when you get healthcare. And in fact, there was a study done showing that African American women were more likely to die in childbirth independent of income or education, right? There was a story of a woman who, African American woman, with a doctorate who actually worked for the CDC investigating infant mortality, and who passed away as a result of birth complications. So race has a lot to do with your access to healthcare and your treatment by healthcare professionals. Income, right? Are you able to afford prenatal care? Do you have access to prenatal care? Education, do you know that you need to have prenatal care? There's a lot more information that goes into these numbers, and so averages can give us a very short picture, but they do not tell the whole story. So to truly understand geography, we have to dive deeper into more data, right? And you could even, again, this is just by state. You could look at a lot more different types of data. And it's something that population geographers and people who work in census do, is they kind of dive deeper into what these numbers mean and how can we improve access to care and improve education based on what these numbers are telling us. And that's why the census is so important, is you want everyone to be counted so we can make sure that everyone is accurately represented and we get accurate support for all populations. Okay, so if we look at the number of people who are passing away and the number of people who are being born, we have to talk about population growth. Okay, so why do some populations grow a lot faster and some populations grow a lot slower? Okay, so if we look at, AD1, oh, there goes my stupid bar there. If I look at AD1, right, so this is the last 2,000 years, you can see we had a pretty stagnant growth through here and then it kind of shot off pretty fast, right? So we've seen an exponential growth, and this is human population, of course. Today in 2020, we are above 7 billion people on our lovely little planet. And so, how do we measure that? And why does it change the way it does? All right. Currently, our population is slowing. We are still increasing, but we are increasing at a slower rate than we have been previously. Okay. So, one way we measure this is doubling time. Those of you who are biology majors will also use this if you are doing microbe petri dish populations, looking at how fast it takes for a microbe population to increase. I think that cancer researchers do this as well in terms of tumor growth. Probably economists do as well. But oops. So looking at the year zero, okay, so year one for our common era. AD is Anno Domini, but we also say common era. Our entire planet had a population of 250 million people. Okay. To put this in context, in 2019, California, the state of California, had about 40 million people, 40, and the entire US in 2018 had about 327 million people. Okay, so by the year, whoops, from the year zero to the year 1650, we went from 250 million to 500 million. Okay, so we went from being less than the entire US to more than the entire US. But it took us 1,650 years to double our population. So at this time, we would say that our doubling time was 1,650 years. To get to the next marker, was then to 1820, which is 100 and what's 170, right? To get to 1 billion. So now we vastly reduced our doubling time. We went from 1,600 years to less than 200 years. Okay. To hit the next doubling time, it took us less than 100 years. All right. Now we're looking at less than 50 years. So this is the doubling time again, is how fast it takes us to double our population. I've seen different numbers. I saw one number that said 54, one that said 61. So I'll just give it a nice average and say that roughly right now the world's doubling time is 55 years. So if we are a little more than 7 billion right now, we'll get to 14 billion in roughly 55 years. Okay, and so that's the idea of doubling time. And so sometimes people talk about a population explosion, because as you see, we've increased quite a bit from, took us 1,000 years here to 40 years here. So Thomas Malthus had a quote: "The power of population is indefinitely greater than the power in the earth to produce subsistence of man." So you might sometimes hear someone say that they Malthusian principles are a Malthusian theory, and Malthus basically believed that humans were going to reproduce so much until we used up our resources and then died out. And kind of the idea being, if you had a bunch of microbes in a petri dish, they would eat all of the nutrients until there was no nutrients left, and then they'd all go extinct. Okay, so Malthus had this theory, and then Paul Ehrlich had a book in the 1960s called The Population Bomb, which had a lot of the same things of like, hey, we're reproducing too fast, we're having too many babies, we're going to use up all of the resources on Earth, and then we're all going to die out. And so a lot of calls for population control has harkened back to this. And so there have been, of course, many comments throughout history of people making references to either Malthus or Ehrlich about reducing population because it's concerned that humans are going to just produce continuously until we use up all of Earth's resources. However, so this if we look about how do we well, I should say how the government, I don't know, how does the government um encourage or discourage people to have babies? If we're worried about this giant population explosion, how do government and policy influences this? So we have different types of population policies. So, for example, you might have an expansive population policy, and we see this in many countries that have a shrinking population. And so these are policies that say, "Hey, please have more babies. Please have more babies." Okay, so we will pay you. There are countries that will pay you to have more babies, right? Because they are so in need of increasing their numbers. So tax incentives to pay you for having babies. More family-friendly services. If you know that you're able to work from home more or you'll have more time off for newborns, you might be more likely to have more children. Okay, there is billboards that say, having babies are your patriotic duty, right? So that's when your government and policies are trying to encourage your population to have more babies, to expand your population. Okay. A more severe one is going to be a eugenic population policies. And these are policies that restrict only specific cultures or races from reproducing. Eugenics is anything that is limiting populations, again, a basis of race and ethnicity. Okay. So this is when women of indigenous tribes and Latinx um, ancestry were forcibly sterilized. This was common, especially on Native American reservations. Women were sterilized without their knowledge and against their will. Um, Additional taxation. So if you have babies and the government has decided that your race or your culture should not be having babies, there's additional taxes on this. Um, this is different than eugenic, like a genocide, where people are forcibly murdered, like we saw in the Holocaust in the 1940s. This is going to be restricting population, so reproduction. Okay, so again, more sterilization. You also there was both in the United States and in New Zealand, Australia, you had the practice where the government would forcibly take children from indigenous peoples and replace them either into white homes and white families or into schools that would then erase their language and erase their culture. And this is another type of eugenic population policy where it's this effort to erase an entire culture. Okay, it's very targeted at a specific culture. Okay. A more broader term of this would be the restrictive population policies. So these are policies that are going to reduce number of children born per family across the board, not just for one specific culture or race. And so fines, if you have too many babies, we're going to fine you. Right? This is a practice in some countries that are more concerned about their population numbers. Increases in abortions and infanticide or murder of babies, quite often of female babies, depending on what part of the world you are in. This could be caused by the government or caused by families who, if they find out the gender of or I should say the biological sex of their baby, either in utero or after birth, and decide we don't want to have a female baby, we're going to abort this fetus or kill this baby in favor of having a male baby later. Okay, so restrictive population policies is the government putting actions in place that are going to reduce the number of children born per family. And all three of these are going to be government and policy driven, all right? Um, it's going to be top down type effect. Now, all this talk about limiting the number of children and these calls for saying, hey, too many babies being born, we need to reduce our population. There's a big concern. This is all just a thinly veiled racist policy, okay? Anytime you say, hey, there are too many babies being born, no one ever says there's too many Norwegians being born, right? A lot of the global dialogue about being too much population growth, too many babies being born. Quite often, this is focused on people of color. All right, so you might hear complaints about, oh, China's having too many babies, India's having too many babies. In the United States, we hear complaints about people from Latinx ancestry or people from African American ancestry having too many babies. All right. So there's a lot of concern that whenever you talk about population control, it really is a conversation about race. Okay. And this is again going to be that concern about eugenics. Is it that we're concerned about there being too many babies being born, or is it concern about which kind of babies are being born? Okay. So anytime you hear anyone talk about, oh, the too much population, be real careful because there's a lot of other subtext happening there. Okay. And so, more and more, instead of talking about too many babies being born, it's more about the amount of resources being used because not all people on all different parts of the world use resources the same. Okay. For example, you may have taken what's called a carbon footprint quiz or an ecological footprint quiz where they ask you things like how much meat do you eat? How much do you drive? Do you use air conditioning? Whatever. There are problems in these quizzes as well, but it gives you an idea of what does your lifestyle require in terms of planetary resources. Okay, and so if we look at it in terms of resources, then we may see that the United States, for example, babies being born in the U.S. are using way more resources than, for example, a baby being born in Uganda. Okay, and so definitely, I want to caution on any conversations about too many people being born, and it's more about what kind of resources are being used, right? Our planet has a large capacity if we use things responsibly. Okay, so again, there's lots of charts showing you how much a baby born in country A consumes versus a baby being born in country B consumes in terms of petroleum products and plastics and whatnot, right? So again, it's more about the resources being used and not just the number of number of babies being born where. Okay, so this kind of brings us back to the last idea, the demographic transition. And so this is a really key geographic principle. And this is looking at how different civilizations move throughout different stages of development, right? And so whenever people do complain about, oh, there's too many babies being born, right? That's not going to happen forever. There's a natural cycle as populations progress through the demographic transitions that are going to change where babies are being born and how many and so on and so forth. Okay. So we're going to go through these steps one by one, these different stages. I want to point out stage 5 is a relatively new one. Okay, we're just starting to see countries falling. Here it says yet to be seen. We are starting to see a few countries fall in this category. Not very many, right? But so stage 5 is kind of some people argue that it doesn't exist yet. But just I want you to know that it might be coming within your lifetime. Okay, so first of all, let's go ahead and just look at what this graph means. Okay, this green line here is going to be your birth rate. Okay, so this is the number of babies born per people per year. In both stage 1 and stage 2, your birth rate is very high. Lots of babies being born. And of course, there are many factors that go into why people have a high amount of babies. One being if you work in agriculture, you need someone to help run the farm, right? Farming is a very labor intensive industry. And if you have a family farm, you need children to help with the chores, right? Another reason for having a large number of babies that we especially see in stage ones and two is going to be that again, not all babies make it out of infancy. So by having more babies, you increase the chances that more will make it to adulthood. Okay. There are, of course, many cultural reasons as well. There are many cultures that value having large families, that your status and joy come from having more children. Different religions promote having more children, so there are many cultural reasons as well as to why we have more children. But we're looking at stage one, stage two, and we're going to have very high birth rate. Okay. Then the red line here is going to be your death rate. So how many people are dying per 1,000 people per year? Okay. And remember, again, if I take my birth rate and minus my death rate, that's going to give me my amount of increase. And that will eventually lead to my population. Okay. So in stage one, oops, stage one, I have a lot of people being born and a lot of people dying. Okay. So my population is pretty low. The population is pretty low. And quite often this is happening because that life is not good, right? People just aren't surviving. There's famine, there's war, there's plague, right? Just life is not good. So we're having lots of babies because they're not going to make it, and a lot of people are dying. Okay, you might have your population periods going to look like this. We're going to talk more about population periods later, but you can kind of just see these shapes that they're showing you how a population is changing. Okay, as we move into stage two, I'm still having lots of children. My death rate is dropping. As my death rate decreases, now my natural increase is getting bigger, and now my population is getting bigger. Okay, because more people are surviving. Okay, I'm still having lots of children, but now people are surviving. So this can mean that we have better medicine, so more babies are making it into adulthood. Might have better agriculture, so less concern about famine, more ability to have excess food stored to help us make it through times of low yield. Okay, so if you have a surplus one year, can you store it so you can eat it later? Okay, so stage two is often linked to improvements in terms of quality of life. Okay, especially around medicine, people living longer, right, and more survival. If I then go into um, stage three, now I'm going to start having less children. So my birth rate is going to begin to decline, not as fast as death rates decreasing. Okay. And so now my population is still increasing, and we're going to have more of influence from immigration. Okay. On stage three, we start to see more introduction of contraception and birth control. And we also see a lot of improvement in economic conditions. Okay, as birth rates are starting to decline. One possible reason that they're declining is that women are going back into the workforce. And so, if they're not raising children, having more children, having less babies, so that they're more in the workforce, increasing economy. And then there's sometimes a correlation with education and such. Okay, so looking at this here, whoops. Again, here, so my birth rate is starting to drop. And my death rate is dropping quite a bit, and it starts to plateau about through here. Okay, so I still have quite a bit of natural increase, but it's starting to kind of cut off. And I know my mouse keeps getting in the way, but if you look at the population period, if you compare my stage two with my stage one, you'll see that kind of a weird, like blunted off shape at the bottom, and that's a result of having less children. Okay, so we're still living the same amount of time, not by average, but it's less children being born. Now, as we go into stage four, we definitely start to have death rates have stabilized, and we've definitely reduced our birth rates quite a bit. Okay, so now our population growth is much slower. Okay, you can see that we have this rapid uptick through here, fast growth, fast growth, fast growth, starting to slow down. And then when we get to stage 4, it's getting quite a bit slower, my growth rates. Okay, so what we started to see in stage 3, we definitely see quite a bit in stage 4. This is going to be more reproductive rights for women, education for women. If women are finishing high school and going to college, we're going to delay having babies until later. Most women wait till after college to have babies. Not all do, of course. More urbanization. So if you're not going to be on a farm, you may not need to have as many children to help you with that. In fact, it might be harder to raise children in an expensive city. And now we have increased infant survival rates. So if there's less pressure to have more children because you don't need them for the farm, and you're not worried about as many passing away, you might be having less children because of that. Okay, so now we have much, much slower population growth because both your death rates and your birth rates are lower. You're going to have improvement in medicine and healthcare access. And then we start to go into the stage 5, which, depending on who you ask, some people think it hasn't happened yet. Some people think that it's already starting to show up. So now with stage 5, your birth rate is actually less than your death rate. That means that more people are dying than babies are being born. And this means that you're going to have a continuously aging population. Your country has a negative growth and your population is getting smaller. Okay, I think that, yeah. So you can see here all these little question marks because we're not quite sure it's happening yet, but you start to have this population drop down. Um, it's very hard to measure this completely because immigration is such a large part of our planet. It's kind of hard to look at economy and anything with that with by eliminating immigration because everything on this planet is fueled by immigration, right? But the theory is that if you have so many more people dying than babies being born because people get older and older people eventually pass away, you will eventually have a decrease in population. Okay. And one way that we can snapshot this demographic transition is by using a population pyramid. Population pyramid, nice, fast visual little treat here. So this is going to be the US population period for 2020. This is from the US Census. You can go to this website and you can look up any country in the world and you can go data all the way back. Some of them go back to the 70s and look at how population pyramids have changed. So what these pyramids do, they divide it strictly by male, by female. I am not entirely sure if this is a result of politics that doesn't recognize non-binary folks, or this is looking strictly in terms of reproduction. I don't know that. Well, they do only look at male and female here. And then so we've got, of course, a very gender biased system. We're gonna have red for women and male and blue for men. And so this here is by age, okay? And this is your population. So if I look at the US in 2020, I have 10 million males in between the ages of 0 and 4. And I have roughly 10 million females between the ages of 0 and 4. Okay? Conversely, I then can say I'm going to have, I don't know, 12 million males in between the age of 25 and 29 versus 12 million females between the age of 25 and 29. Okay? Pretty even both sides. You see some fluctuations here. You can talk about US economy, less babies likely to be born in terms of depressions and recessions. So we might see changes in those who grew up during the recession of the 2008s versus the 1970s had a recession. And then as you get higher up, we see as I go above 100, I have more women over the age of 100 than I have men over the age of 100. So you can compare both male and female by age category. Okay, as we saw in your previous slides, looking at the shape of population pyramids, the shape of your pyramid is going to have a lot to say about what your population is doing. Okay, this roughly corresponds to stage 1, stage 2, then stage 3, 4, stage 4, 5. Okay, so this is going to be comparing Angola, which is in Africa, to Japan, and these are both for 2010. If I look at Angola, Angola has had a lot of civil war, a lot of pretty severe violence in Angola. You can see that there's a rapidly expanding pyramid here. A lot of babies are being born, but they're not making it to adulthood. Okay, so you look at, if I have 1 million babies being born, by the way, 1 million babies being born, or 1.2 million babies being born in 2010, I only have, 200,000 people, 200,000 women over the age of 55 to 59. All right. So this kind of pyramid here gives you the idea that we have lots of babies being born, but lots of people passing away. So this gives you a hint that you might have more of a war conflict, especially if you see the male gender being hit harder. That might be an indication of war as well, if you have a country that conscripts its males, or draft its males rather. Um, and it also is going to be indication, maybe less access to healthcare, maybe less access to food security. All right. So this is going to be what we think of as stage 1, stage 2 demographic transitions. Compare that to Japan. If I look in 2010, I had less than 3,000 girls were born in the year 2010, but I have 5,000 women between the age of 60 and 64. So I have more women in their 60s, about retirement age, than I have babies being born. Okay, and this pyramid here is going to be 4 and leading into 5. Japan isn't fully into stage 5 yet, but it's definitely getting there. They'll probably be one of the first countries to get there. Um, as you have an aging population, this is going to throw off your dependency ratios. If I have a lot of people retiring who are then dependent on a smaller number of people who are working, that might be an issue for your economy. Okay. You can think about if you have one child caring for 2 elderly parents, that can be a concern, right? So this is going to be, again, more towards that contracting type. And you can compare, again, so you had compare Angola to Japan, two very different countries, different types of healthcare system versus different types of social support system, different types of governments and economies. And you can see how this impacts the demographics, the population of your entire country. Okay. Whoops. That's all I have for you on this. Feel free to let me know if you have any questions, and go ahead and take your quiz. This is your last lecture before, if you're in my world geography class, not if you're in my cultural. If you're in my world regional geography class, this is your last lecture before your midterm. Okay, so the midterm, this is fair game for the midterm. Yes. All right. Thank you so much, and take care. Bye.